Christmas tree production is a staple industry in Nova Scotia and in Atlantic Canada as a whole. According to Statistics Canada, Nova Scotia's annual Christmas tree exports are valued at more than $7 million. About 90% of the trees harvested in Nova Scotia are exported out of the province, either through brokers or customers in Canada or abroad. The largest markets for Nova Scotia trees are in the United States and Panama, with the remaining markets in the Caribbean, but some as far away as the United Arab Emirates. There is estimated to be more than 15,000 acres of Christmas trees in production in Nova Scotia, with the majority in Lunenburg County. Lunenburg County holds the proud title of the balsam fir Christmas tree capital of the world. There are about 300 growers producing Christmas trees in the province. The Nova Scotia Christmas tree industry provides 4,000 full-time and part-time jobs and keep deep roots in the province's history. Recently, the industry has seen spikes in demand as younger consumers request sustainable and environmentally friendly products that have the bonus of providing a family experience during the holidays. Investments in research paired with government support have lined Nova Scotia up to be the leader in production. If there was ever a part of you that wanted to gear up a Christmas tree side hustle, now is the time. Atlantic Canada is the perfect place to easily grow balsam fir trees because they are native to the area and resilient to our geography and ever-changing weather. Lot management is still crucial to harvest the ideal Christmas tree faster with more profit to the producer. An ideal site for growing Christmas trees in Nova Scotia needs to be accessible, be a frost-free area, is clear enough for a tree to produce a traditional tapered shape, have either eastern or northern exposure, good drainage, and low ground cover. A Christmas tree can be grown on farmland as long as wet spots are avoided. Christmas tree lots can be set up in three basic styles: natural regeneration with interplanting, or plantation style. The style will be determined based on the land, the equipment, and the resources that you have at your disposal for the next 8 to 12 years while the trees are growing, as well as how you intend to market your trees. Most tree lots in Nova Scotia are natural regeneration style. This means that the trees have been encouraged in areas where they already exist. Cutover stands were thinned to expose fir, and those fir trees were encouraged and allowed to produce seed. As a result, more natural regeneration stands have tall seed trees and sale trees at a variety of ages throughout the lot. This style makes seedlings cheap and effortless. However, with natural regeneration, old seed trees are prone to pests and diseases. There's a limited control over density and planting locations, and the lots are generally hard to manage, requiring manual amendment applications, shearing, and harvesting. Some growers opt to interplant seedlings into natural regeneration stands. This style is called natural regeneration with interplanting, and it can result in better genetics, density, and planting control compared to natural regeneration alone. Parts of eastern Canada and the U.S. have adopted to the plantation style, which involves planting trees at a predetermined spacing in rows across a field or in a plantation style, like a monoculture. This allows for density control, drastically improves accessibility, and simplifies management and harvest. However, in some cases, plantation requires more management work, such as mowing in between the rows and pest and disease control. Yields depend on the lot style. However, growers usually aim for planting a density of 1,200 trees per acre. The industry is currently supported by numerous technical resources, educational opportunities, and research projects. Since 1975, the Christmas Tree Council of Nova Scotia has been supporting growers and working with government and the public and other organizations to ensure that this important industry continues to be sustainable and thrive. The Christmas Tree Council of Nova Scotia is an umbrella organization and coordinating body for the 3 regional-based Christmas tree grower associations in Nova Scotia. The associations are the Lunenburg County Christmas Tree Producers Association, the Northeastern Christmas Tree Association, and the Cobequid Christmas Tree Producers Association. Outreach and collaboration is also happening into Cape Breton, Prince Edward Island, and New Brunswick. Reaching out to the Christmas Tree Council of Nova Scotia, your local association, or Perennia are the best ways to learn about opportunities within your area. Jay Woodworth is the Christmas tree specialist at Perennia. CTCNS has an extensive library of resources, research, and educational material for producers, the public, and new entrants in the industry. ctcns.com, iloverealtrees.com, media.ctcns.com, ChristmasTreeForum.com, and the various social media outlets host an incredible amount of resources for production in fact sheets, peer-reviewed articles, website links, videos, and podcasts. Topics covered on all these platforms are soil fertility, business planning, integrated pest management, health and safety, succession planning, new entrants, and much more.
This is the life cycle of a Nova Scotia grown Christmas tree. The trees that we have in our homes come December started its life as a small seed. These seeds can have their start either in a nursery or germinate naturally within a Christmas tree lot. Lots that rely on natural regeneration rely on seed sources from nearby seed trees within or surrounding lots. And growers that rely on interplanting purchase seedlings from a nursery that are anywhere between 1 to 5 years in age. Growers that rely on natural regeneration don't have to plant, but often have to be concerned about thinning after the trees have established within lots. Thinning seedlings is important because it will give the trees optimal room and sunlight to grow without competing with nearby trees as well as weeds. Growers that use interplanting will often plant either in early spring or in the fall. Once trees are established in lots, it takes anywhere from 5 to 7 years for a tree to become marketable. Throughout this time, growers have the option of implementing management practices that can reduce the time that it takes for a tree to become marketable. And some examples of management practices include weed management, insect management, thinning, fertility management, and others. But again, employing the use of these measures can reduce the amount of time that it takes for your trees to become marketable. Once trees reach a marketable size, growers can sell their trees either wholesale, retail, or in a U-pick operation. And once sold, these trees will end up in our homes, in retail settings, as well as in places such as city centers for everyone to enjoy. Once the holiday season is over, and it's time to take your Christmas tree down or dispose of your Christmas tree, there are often a few options. Some cities provide Christmas tree collection in January. Often Christmas trees are burned at the end of their use in January or often tossed outside and used for wildlife areas. Some wildlife will use these disposed of Christmas trees as an area to nest and for protection. And there you have it. There's the life cycle of a Nova Scotia grown Christmas tree. And come December, we can have a better understanding of the life cycle of the tree that we have in our home, as well as the inputs needed to grow that tree. These are the flushing stages of balsam fir. With the onset of warm temperatures in the spring, it causes balsam fir to emerge from winter dormancy. These warmer temperatures signal the tree to begin growth for the year. There are about 7 stages to a balsam fir in flush. Often the buds will begin brown, hard to the touch, and covered in a waxy coating. And over spring, the waxy coating will dissipate, the buds will begin to swell, and often turn a brown-white color. The white color often occurs when the buds are swelling in size. Later in the flush, you'll begin to see a bit of green at the tips of the buds or at the base. This is often where the bud will break and the new growth will emerge. And within the bud, there is what's called leaf primordia. These leaf primordia, once they exit the bud, will begin to stretch and grow, and this will become your current year's growth. These leaf primordia are the future needles of the tree. Depending on the tree and location, this process can often take up to a month or more. Once a tree has finished flushing, the new growth will be quite light green in color compared to the rest of the tree, as well as the tips will be quite tender. The new growth at this point is very delicate, so it's important to be careful when handling trees or doing any sort of pest management. And it's important to note that in Nova Scotia, we seek out late flushing trees, as we often have a danger of late June frosts in our growth season. In spring 2021, The Christmas Tree Council research team was able to do a pollen collection in the DeBert Christmas tree orchard. Trees were ready for pollen harvest in mid-May. Pollen was collected from various lines of trees to use in specific crosses later in the summer. Materials used to collect pollen included a ladder, long pole pruners, as well as leaf bags. The male cones of the balsam fir are the cones that produce the pollen. These cones are much smaller in size than the female cones found at the top of the tree. The male cones are often circular, very small, and are placed on the underside of the branches lower on the tree. The research team removed these male cones from the trees and placed them in the leaf bags to dry. Drying increased the yield of harvested pollen, and once these cones were dry, it was also much easier to remove pollen. Cones were placed on a screen to allow us to sift the pollen off of the plant material. The remaining plant material was discarded, but the pollen was collected and placed in plastic bags and labeled for future use. And again, this pollen was used to produce specific crosses of Christmas trees in Nova Scotia. And later in the year, when the female cones were ready to be pollinated, and the pollen that we had harvested earlier in the year was used to pollinate these cones.
Hi there, my name is Andrew Schofield and I work at the Biology Department in Dalhousie University, and I also work with the Christmas Tree Council of Nova Scotia and with the Smart Christmas Tree Cooperative to coordinate their tree improvement program. So this program has two main objectives. The first objective is to find great trees. So for decades now, CTC&S has been working with growers and with various organizations to identify trees that have superior traits. So for example, we're interested in things like overall shape, color, needle retention, brush quality, spring flush time, and also how well they hold their needles after they've been harvested. We're preserving these great trees by grafting them to various orchards around the province. The second aim of the tree improvement program is to make varieties of balsam fir trees. So for example, this is a really common practice in agriculture. So many consumers would know about apple varieties like Honeycrisp, Gala, or Ambrosia. And perhaps more importantly, farmers know the performance of and the particular production requirements of these various varieties. We create these balsam fir varieties using a tissue culture technique called somatic embryogenesis, or SE for short. And although it sounds pretty fancy, it's actually a very old technique. So we're not altering the genetics of these trees or creating GMOs. All we're doing is taking the young, developing seedling from out of the seed and causing it to make multiple copies of itself. The result is hundreds of thousands of natural trees. And since they're all genetically identical copies of that original tree, they constitute a new variety of balsam fir. This year we used controlled crosses with superior trees to create new SE varieties. In the early spring, before the pollen had started to come out of the trees, we placed bags over the female cones. When these cones were receptive, we artificially introduced the pollen back into the bags, and that way we were able to control the mother and the father of the cross. Later in the summer, we harvested these seeds and cut them open to remove the embryos, which are the developing plants within the seed. We placed these embryos on special tissue culture media. Over the coming months, some of these embryos will begin to make multiple copies of themselves. These new SE varieties will be sent to our partner in Prince Edward Island, who will grow them out for field trials. And eventually, some of these best SE varieties will be used for commercial production.
Today we are removing the pollination bags from the trees. These bags have been used to control the fertilization of the trees. So we know the mother, obviously, but each bag on the tree contains the pollen of a different father. So we are able to do controlled crosses, which we will be using. We'll take these cones and take out the embryos from them to be used in future smart tree trials. Okay. Here's a bag, and we'll note the cross. So this is the cross 34. And re-tag it so that in a few weeks when the cones are mature, we'll come back and collect them to then remove the embryos in the lab, where they can be stored in cryo storage until we're ready to commence our trial. We're going to tag the tree where it was pollinated. We also want to take stock of how many cones are on each cross so that we can then plan our collection appropriately, so we're not running around the orchard from tree to tree. We'll plan it according to how many cones are on each tree. So here we have a balsam fir cone. The first step once we get it back to the lab is to remove the resin, which is very sticky. We do this by spraying 70% ethanol and then scrubbing the cone with a paper towel. Once the sap has been removed, we can then remove the seeds. So we start by twisting the cone, and then this would snap it in half, and then we remove each petal, which has 2 seeds on it. These seeds are then placed in cassettes to be analyzed. Once we have the seeds removed, we can begin to dissect them. First, we put these seeds under a microscope, and with a scalpel and fine tweezers, we slice through the cell wall into the seed, trying to expose the gametophyte. What we're trying to see is how healthy the gametophyte is. If it's pearly and white, it means that the gametophyte is healthy and has a good chance of producing offspring. But if it's dead, meaning shriveled up, or brownish, we discard it, and then As you can see, unfortunately this is a dead gametophyte. As it's shriveled up, it won't produce offspring. So we note how many from each cone are dead and how many are alive to determine the viability of the cone. This information allows us to determine if we should continue cleaning all the seeds in the cone or discard it. Here, you can see that we're using the microscope to open up the seeds. This seed in particular is a healthy gametophyte. Once it has been determined that the seed is viable, then all the seeds from the cone are removed. They are then sterilized before beginning the next step. Once sterile, in a sterile environment, they are cut open to remove all the healthy gametophytes to then be placed on a culture medium to grow. The goal of this project is to create the next generation of smart trees. Hopefully, in the near future, you'll be seeing these smart trees growing in Christmas tree lots around the province.
All right, good morning. This is Jay Woodworth, the Christmas tree specialist with Perennia. I am here today standing in one of our CLMT research sites. So this is one of 9 field evaluation sites for the Smart Tree Development Program. So we had funding to set these sites up through the Canadian Agricultural Partnership's Crop and Livestock Management Trials. We were able to put 3 in each Christmas tree region across the province. So we've got 3 up in Lunenburg County area, we have 3 here in Cobequid area, and we have 3 up in the northeastern region, which covers Antigonish and Guysborough counties. So in these 9 plots, what we've been able to do is actually work on planting out a generic row kind of situation, 6 by 6 foot spacing of Christmas trees. These are all smart tree clones with the exception of the blanks that are in here, and we've got about 44 trees per site. So because we have so much deer pressure here in Cobequid region, we actually ended up fencing out each individual tree on the site. This wouldn't be a practical solution in an actual farm environment, but it works to maintain the integrity of our trees here, as deer are one of our main pests that we're seeing in Cobequid region anyway. So you can see here each of these trees. So this one's about 3 foot in height. There's one on my left hand side as well that's a little bit taller. What we're looking for in the Smart Tree program is trees that are late flushing. So we'll pan in a little bit later on this tree to my left, but you can see it's the middle of July and this tree is still pretty fresh, pretty new with the flush. So that's great news. We also look at needle length, so we like to see trees that have longer needle length. We also look for needle retention, so there's a fine balance in there, getting trees that express both characteristics. We look at color, so often we go for either that really deep dark emerald green color or sometimes the blue tinged or silver tinged under needles. So the trees that we're finding through the Smart Tree Development Program, we have identified crosses, so parent trees that have really good characteristics from Nova Scotia mainly, and from New Brunswick in some cases. We've strategically crossed them so that they're expressing genetic traits. So it's an entirely natural process. It's just a little bit different because we're actually growing up these seeds in a petri dish and getting them ready for mass production. So the trees that are here, this is the first time that we've been doing a field evaluation on the trees. So these were grown in the lab, and now they're planted out in a natural site to see how well they do in a natural environment that we would see across the province. So we're going to walk around and show you some of the different lines. Keep in mind we are just in Cobequid, so the different lines will express themselves differently depending on what environment they're planted into. So if you're looking to plant smart trees in Lunenburg County, for example, it would be more useful to look at the Lunenburg data, which is maybe where we should have gone today because it's raining in Truro again. Okay, so this tree here has a barcode. So this was one of the trees that we would have actually planted out last year. So this would have been planted in 2020 in the spring. We've got a barcode tag here, and we bring the barcode scanner out with us when we go to evaluate the trees. So we're just able to scan the tree identification directly into our spreadsheet, and then we evaluate them for some of the characteristics that I discussed earlier. This is tree 242. So this is one of the older crosses in the Smart Tree program. It's expressing some really good budding. So you can see if you go through and count the internodal budding, we've got 1, 2, 3, 4, 5, 6, 7, going right on. And for a tree of this height, that's showing some really good budding. We're also starting to see some nice color. This tree was a late flusher as well for Cobequid region. So that's a good characteristic to keep in mind. And it's staying relatively healthy for being planted out in a site like this. We did have some trees that were hit with frost in this area. Some of our blanks are looking pretty hard, but these ones look really good. So we're happy to see that some of the smart genetics are successfully being expressed in the field. It's going to be a 10-year cycle to get this tree to fully harvestable rate, but we're still really happy to see that even in just a couple of years of field evaluation, we can see some of the characteristics that this tree was bred for. Alright, just going to show you some characteristics on this tree here. So this tree, quite a bit bigger, hasn't been sheared yet this year. It could really use it. You can see how much growth we had this summer here in Nova Scotia. Just really phenomenal. What I want to point out on this tree, it's a lot easier to see some of the characteristics that we actually evaluate our tree genetics for when they're a little bit larger. So this tree, very uniform, pretty hard to see the stem here, so there's a lot of stem coverage, which means we've got great density of foliage throughout this tree. You can also see there is quite a bit of bottled brush happening on this guy, so you've got your needles 360 degrees around. And on some of this newer growth, you can see when I hold this branch up here, there's a little bit of a silver or blue flash on the underside of the needles. That's really desirable with consumers, so that just gives you a little something extra special with the tree. So to have a balsam fir that is expressing really good needle retention, is showing really good foliage characteristics, and also has that nice silver blue flash, that's really great for the industry here in Nova Scotia. So just wanted to take a minute and point that out on some of the larger trees that we have in the program. This tree here is another smart tree line, so this one would have been a little bit younger. It's been planted out more recently. This is one of the replicates of 238, so there aren't a lot of 238s planted around the province. So we're just getting into the field evaluations with these guys. This hasn't been sheared yet, obviously. We're seeing some pretty good growth, pretty uniform tree, nice bottle brush that you can see here. We're still waiting to see what the needle length is going to be, but overall, healthy tree. And if you look around, some of the other conventional seedlings that are here have suffered a little bit more insect and disease damage, so it's nice to see that the smart trees are still doing well. So here's another 238. This one would have been a little bit older than the last one that we had just looked at here. So it's when they start to get older, it's a lot easier to see some of their phenotypic characteristics. So you can see here this tree's got pretty good bottle brush, quite a bit of internodal budding. It's going to have decent needle length, and the uniformity of this tree is just pretty good as well. This one could use a shear, but other than that, just looking at the buds that are forming on that tree is really nice to see.
This is an example of some of the trees that we have planted on these sites. This is clone line 245. It was planted out in the fall of 2020. This is one of 9 smart tree evaluation sites that the Christmas Tree Council of Nova Scotia has planted out across the province. This one is located in Wolfville, Nova Scotia. This is one of 3 smart tree evaluation sites found in the Lunenburg region. So, Barks Corner Road. Half of these seedlings were planted out in fall 2020, and the other half planted out in spring of 2021.
So this is the Riversdale smart tree site. As you can see, it was a clear cut, so it's hasn't been in Christmas tree production before. Currently all the cages are off because we're just dealing with a pest issue, but yeah. All the trees are tagged for identification. This is the site at Woodworth Mountain, the CLMT site. There's still quite a few trees left to go into this research plot. This is the Belmont CLMT site. Fortunately, this site was hit quite hard by frost this year, which is unfortunate, but it gives some clear directive of which trees are a little hardier.
Alright, this is our CLMT trial site at Chrissy Chen Homes. Weed control is much better here. We have our yellow flag trees, which are the CLMT smart trees, and the pink ones are blanks. Each tree has been mulched and barcoded. Alright, so this is the Middleton site, Scott and Stewart's lot. We have the CLMT trial set up here in their balsam fir lot. These are what the trees look like. They're planted in rows here in a grid. The yellow flagged trees are our CLMT smart trees, and the pink flagged ones are the blanks. The trees down this line have been planted for over a year now, and so have these guys right here, and then the row in between them right here and the far line were planted at the end of the spring. Alright, so we're at our CLMT trial site at Scott McKinnon's. Here is the grid of trees. We have the CLMT smart trees pegged in yellow. Each tree is caged and mulched, barcoded and tagged. This site needs to be mowed, but here is the plot. The pink flagging tape are the blanks, so they are not smart trees.